All right, have you ever really wondered if a machine could predict a game of soccer? With all its chaos and unpredictability? Well, today, that's exactly what we're going to break down. We're going to look under the hood of a sophisticated AI model to see how it tackles a real-life match, step by tiny step.
So here's the big question, right? Can an algorithm really predict 90 minutes of pure human effort, skill, and just plain luck? To figure that out, we're going to watch how one AI analyzed a super-specific matchup from Spain's top league, La Liga. The two teams in the ring are Levante UD and Rayo Vallecano. And as you can see, they are practically neighbors in the league standings, sitting at 13th and 14th place. So this isn't some kind of epic showdown between a giant and an underdog. Nope. This is a clash of equals, which makes picking a winner incredibly tough for anyone, human or machine. So I'll just ask you, looking at that, who do you think's gonna take it? It's a tough call, isn't it? Well, an AI model called Spectra thinks it has the answer. And that's what we're gonna do now. We are going to peel back the layers of its digital brain to understand the logic, the data, and the whole process it uses to make a final call. Look, every complex prediction has to start somewhere. And for this AI, it starts with the absolute fundamentals. It's just like a coach building a team. You've got to master the basics of player strength and scoring before you even think about the fancy stuff. Okay, so the first building block is something called an ELO rating. Now, if you've ever played a competitive video game or even online chess, you know exactly what this is. It's basically a score that goes up when you win and down when you lose. It's a fantastic way to get a live, constantly changing measurement of how strong a team is right now. And check this out. When we look at the actual numbers, Rayo Vallecano has a slightly higher ELO rating. So based on this one metric, you might just give them the edge. But you gotta remember, this is just the very first piece of a much bigger puzzle. Next, the model starts thinking about goals, the thing that actually wins games. It uses a tool called a Poisson Regression. So while ELO tells us about overall strength, this thing is laser-focused on predicting one specific event, the number of goals a team is likely to score. And this is where the plot thickens. The model predicts Levante, who's playing at home, will score almost 2 goals, 1.94 to be exact. But it thinks Rayo will score less than 1. All of a sudden, that slight ELO advantage Rayo had is being seriously challenged by Levante's home field advantage. Interesting. Okay, so we've got our basic stats. Now, it's time for the AI to call in the specialists. You can think of these as a whole team of expert analysts, and each one has a totally unique way of looking at the data to find patterns the simple formulas might have missed. And this team is seriously impressive. You've got models like random forest and even a neural network, which tries to find hidden connections, kind of like a human brain does. Now, you don't need to be a data scientist to get this. Just know that each one of these specialists is analyzing all the data from a completely different perspective. This really gets to the core idea of what's known as ensemble learning. It's simple, really. You don't rely on just one genius. You get opinions from a diverse group of experts. And just like in the real world, that collective wisdom is almost always way more powerful than a single point of view. So, now we've got all these opinions floating around. We have the foundational stats, and we have the analysis from our whole team of AI specialists. That's a lot of information, and some of it probably conflicts. We need a head coach to listen to everybody and make one final call. And that's exactly what a stacked model is. It's a meta model, our head coach that sits on top of all the others. Its only job is to learn which of its specialists to trust in any given situation. It weighs all the evidence to come up with the single most likely outcome. So after all that, what did the head coach decide? All right, the final verdict is in. The head coach model gives Levante, the home team, a 15.95% chance of winning. That's not exactly a ringing endorsement, is it? And then look at this. The chance of an away win for Rayo Vallecano is 15.70%. Whoa, that is unbelievably close. We're talking about a difference of less than 0.25%. It's basically a coin flip. So, you're probably doing the math in your head right now, wondering where all the rest of the probability went. Well, here it is. The model's final prediction, with a massive 68% probability, is a draw. After weighing absolutely everything, the AI's best guess is that nobody wins. But wait, the AI isn't done yet. A prediction is one thing, but to be really confident, you need to stress test it. So the model does something pretty amazing. It simulates the game over and over and over again. It's called a Monte Carlo simulation. And what that really means is, using all the probabilities it just figured out, the AI basically plays the match 10,000 times in its own virtual world. This way, it can see which scores and outcomes pop up most often, giving us a much clearer picture of what's likely to happen.
And the results from those 10,000 virtual games are pretty incredible. The single most common final score is a 1-1 draw, which happens more than 11% of the time. This just adds even more weight to the AI's prediction of a draw. It's not just the most likely outcome, it's also the most likely specific scoreline. Now, to put this all in perspective, here's how our Spectra AI's prediction compares to another one from around the web. While our model is very confident about a draw, this other source is calling for a wild 3-2 win for Levante. It's the perfect reminder that these are all just probabilities, not prophecies. And that right there is the most important thing to take away from all of this. AI isn't magic. It isn't a crystal ball that sees the future. It's a tool for doing incredibly advanced statistical analysis. It's a logical, layered process of weighing evidence from every possible angle to make the most informed guess it possibly can.
It really gets you thinking, doesn't it? This same kind of layered, evidence-based approach is already being used in everything from medicine to finance. So, the question I want to leave you with is this. If this is how a machine makes a decision about a simple soccer match, what does that tell us about how we'll be making all kinds of critical decisions in the future? Thanks for joining me.